So we should now discuss in great detail complex 1. Okay, now you should understand, suppose this is the mitochondrial outer membrane and this is mitochondrial inner membrane. Okay, now listen, suppose there are, now listen, the complex proteins, okay, are present here like this, small tiny proteins. Now listen with all your attention, they are loaded with, these membranes are loaded with those proteins. Now listen with all your attention, you should understand one thing. Now listen, now this is complex 1. Okay, suppose I am drawing it out of proportion to make you people understand. Okay, complex 1 is not at all that much big. Okay, now listen, suppose this is complex 1. Okay, so we will get rid of this Christie so that we can actually draw this complex 1. Listen with all your attention. Now listen, now you should understand one thing. Suppose this is the cell, this is suppose cytoplasm or cytosol. Now listen with all your attention, this is cytosol and this is matrix of mitochondria. Now you should understand one thing, that is, suppose in the matrix, you know, TCA cycle is going on and TCA cycle is giving out NADH. Okay, now listen, now this NADH is the electron carrier right now, we have already discussed this. Now listen, when this NADH is going towards the complex 1, what will happen is, there is FMN, right? There is FMN and FMN will take 2 electrons from NADH and NADH will be oxidized. Now listen, NADH will be oxidized and 1 proton will be released. Now listen with all your attention. Now you should understand that when NADH is giving electrons to FMN, that is, it is oxidized and FMN is reduced. Now listen with all your attention. When FMN is reduced, what is the basic important concept related to oxidative phosphorylation or TCA cycle, sorry, ETS, that is, when a particular prosthetic group of a protein is oxidized or reduced, then in the next event it will be oxidized or reduced. Now listen, what is the meaning? FMN in this case has been reduced by the addition of electrons from NADH. That means NADH is now oxidized, right? NAD is now oxidized and FMN is now what? Reduced, right? Now in the next turn, FMN will be oxidized and some other protein will be reduced. That means FMN in the first cycle is going reduction and in the next cycle it is going oxidation. That means ETS can be very well explained if you understand it this way, that it's nothing but a oxidoreductive cycle going on in the mitochondrial inner membrane. Okay, not only mitochondrial inner membrane, it is actually going on in the prosthetic groups of mitochondrial inner membrane proteins, right? Okay, now listen, from FMN, you should understand, from FMN these electrons are passed through four I have already discussed iron sulfur cluster, right? You're right. I've already discussed what is iron sulfur cluster. Now listen. From this FMN, electrons are moving from the first iron sulfur cluster to the second iron sulfur cluster, third and fourth. Now listen with all your attention. I have already discussed that there are actually 3 types of iron sulfur cluster, that is FeS type, 2FeS type, which is present in complex 3, that is known as Rieske center. We will be discussing it later, and 4Fe and 4S cluster. Now listen. These are actually 4Fe 4S clusters. These are not 2Fe 2S cluster. Okay, that's a very basic difference between the iron sulfur cluster present in complex 1 and complex 3. Okay, now listen. From now, when this electron is coming towards this first iron sulfur cluster, it is reduced. Now these electrons will now be transferred to the second iron sulfur cluster, okay, then to the third, then to the fourth. That means at the end this iron sulfur cluster will be reduced and this will be oxidized, now reduced. Now listen, this 4Fe 4S cluster has now 2 electrons and it should be passed to a particular carrier. Now listen, this 4Fe 4S cluster now passes on its electron to ubiquinone. This is ubiquinone, passes on its electrons to ubiquinone. Now listen, you should understand one thing, that how ubiquinone changes its form when electrons are added to it. Now listen, whenever there is something called Q and you add an electron, then Q will become negative, right? This is called ubiquinone. That means it's a ketone. Now listen, whenever you are adding electron to ubiquinone, it is converted to semiquinone. Okay. Again, when you add another electron, you can add maximum of 2 electrons to a ubiquinone molecule. When you add another electron, it becomes -2 and it acquires H plus from its surrounding and it becomes QH2, which is known by the name of ubiquinol. Okay, it's an alcoholic form. These two are ketone form because there is one, and this is the alcoholic form. Okay, now listen. Why are you laughing? Okay, now listen. These iron sulfur clusters, these iron sulfur clusters now presents the electron to quinone and it is converted to ubiquinol, right? It is converted to ubiquinol, right? It is now converted to ubiquinol. Now listen with all your attention possible. It's a very important part, this transfer of electron from iron sulfur cluster present in complex 1 to quinone and subsequently conversion of quinone to ubiquinone to ubiquinol is very important. Why? Because I will tell you. Have you heard of the term barburates? Have you heard of the term amital? Have you heard of the term rotenone? These three things you should remember when you are discussing complex 1 and its poisons. These three things you should remember when you are discussing complex 1 and their inhibitors. Complex 1 has mainly 3 inhibitors, that is amital, rotenone, it's a plant product, okay, rotenone is a plant product, and barbiturates. These three are inhibitors of complex 1. Whenever we are discussing inhibitors of complex 1, we should discuss this, right? In many exams, you are asked the mode of action of rotenone, barbiturates and amital. Now listen, it's very easy for you to understand, because all these three things inhibit the same electron transfer process, or these three things inhibit the electron transport system in the same place. That is, they inhibit the electron transfer, they inhibit the electron transfer in the same place. That is, they inhibit the transfer of electrons from 4 iron sulfur cluster to ubiquinone, that is, they inhibit here. They inhibit here. Amital, rotenone and barbiturates. They inhibit here, okay, that is, they inhibit the electron transfer from iron sulfur cluster to ubiquinone of complex 1. Now listen with all your attention. Suppose your complex 1 is completely fine and it is not, inhibited by any inhibitor. Now what will happen? What will happen after that? Now listen with all your attention possible. Now QH2 cannot leave, this QH2 or ubiquinol cannot leave complex 1. It is bound to complex 1. Why? Because it is a prosthetic group. Now listen, this QH2 now handovers 2 electrons to another iron sulfur cluster, and this iron sulfur cluster will now throw the electron outside of this membrane. That means there is a very basic thing you need to understand, that is, it will throw the electron in the mitochondrial membrane itself. That means if you just think like this, this is the part of the membrane, right? Robertson unit membrane concept. So all the membrane should be identical with respect to phospholipids and all, right? Now listen, obviously protein component should be different. Now listen, these 2 electrons now are transferred to a ubiquinone which is sitting between the lipid bilayers of the inner mitochondrial membrane. Now you should understand this very carefully. Now listen, whenever NADH is giving electrons to FMN and FMN is passing the electrons to ubiquinone via 4 iron sulfur cluster, and that electron is transferred to the final iron sulfur cluster. Okay. Now listen, this final iron sulfur cluster now transfers the electron to that ubiquinone which is sitting in between the lipid bilayer of the inner mitochondrial membrane. Okay. That means what you can say about this ubiquinone? First, it's a mobile ubiquinone. It's a mobile ubiquinone, sorry. Second thing you should understand, you can tell about this ubiquinone is that it's a hydrophobic molecule. Don't you think so? These two characters are very important. Now listen, when this ubiquinone accepts electrons, it is converted to ubiquinol, and it will transfer its electrons to complex 3, not 2. Now it will transfer its electrons to complex 3. Okay. Now up to this you have understood, right? Up to this you all have understood what is going on. Okay. Now listen with all your attention. Very few people know that there is a basic difference between the NADH which is coming from glycolysis and NADH which is coming from TCA cycle. What is the difference? They are NADH, right? Obviously they are NADH, no doubt about that. But the basic difference is this: the NADH which is coming from, listen, everyone who is watching this video also should know that NADH which is coming from TCA cycle is present in the matrix itself. Right? And any NADH which is coming from glycolysis is actually present outside the mitochondria, right? And that poses a problem. That poses a very serious problem. Why? Because suppose this NADH wants to participate in electron transport system, but the problem is this: it is very much easy for this NADH to go through the outer mitochondrial membrane, but I have already said, right, that inner mitochondrial membrane is highly selectively permeable. That means this NADH will not be allowed to cross the second membrane, to cross the inner mitochondrial membrane. Okay. This NADH will not be allowed to cross the second mitochondrial membrane. That's the very biggest problem right now. How to solve this, right? Listen with all your attention. Whenever I am talking about NADH which is coming from TCA cycle, I am talking about those NADH which are already present in the matrix. But whenever I am talking about NADH which is coming from glycolysis, I am talking about NADH which is coming from outside the matrix or outside the mitochondria. That poses